Welcome to Heek Suit Draconis. Here be dragons. Today, I wanted to prepare my viewers for some upcoming videos, including my next video, which looks at just how healthy organic foods really are, or are not. And I think the best way to get those debunking juices flowing is to look at some quick science myths that still keep persisting to this day. You may laugh at these, you may not, but be aware, many people still think these are true. There is no gravity in space. That is wrong. Gravity is everywhere, literally everywhere, as it is a distortion in space-time caused by mass, though it does reduce the further you get away from it. However, your average astronaut still weighs about 90% of what they weigh here on Earth. The reason things appear weightless is because the space station and the things inside of it are all moving at the same speed. Basically, the ISS is falling so fast that it keeps missing the Earth. But the station and everything inside of it is still in free fall, meaning everything is moving at the same speed and no outside force is being applied. If the ISS was to stop all of a sudden, and we had some inertial compensator from Star Trek to prevent people from turning into insects on a windshield, everyone would instantly feel pretty much just like they were standing on Earth. That is until the station reached terminal velocity as it fell back through to the Earth. And then everyone would again appear to be weightless, until the ground made its appearance. Next, the Great Wall of China is the only man-made object you can see from space. Yes, no, yes. It's one of those. In low Earth orbit with a large enough zoom lens, you can see the Great Wall of China. But you can also see many other man-made objects. And at a higher orbit, you cannot see the Great Wall of China. But you can see many cities. Even though the Great Wall of China is very long, it is not wide enough to be seen from any high orbits without a zoom lens, as it is only 4 to 5 meters wide, or, for you cavemen out there, 13 to 16 feet wide. Next, carrots let you see better. No. Carrots contain beta-carotene, a substance that the body converts to vitamin A, which is an important nutrient for eye health. An extreme lack of vitamin A can cause blindness. Vitamin A can prevent the formation of cataracts and macular degeneration, which is the world's leading cause of blindness. However, the amount in carrots isn't enough to make a difference in your eyesight. So where did this come from? World War II and, you know it, the British. In World War II, the British invented the radar, but they had to keep it a secret from the Germans, which meant finding a way of explaining how they were able to constantly spot German aircraft from extremely far distances. The British just said, "Our pilots eat carrots, they help with their eyesight." And, believe it or not, the Germans bought it, for a bit at least. A penny dropped from the Empire State Building can kill a person on the sidewalk. And this is a myth. So if you were to drop a penny from the top of the Empire State Building, it would accelerate to the point that it could kill a person on the sidewalk below. This is just really bad physics. In reality, the penny will reach terminal velocity, which can range from 30 to 100 miles an hour, just depending on the wind, as it gets pretty windy around those skyscrapers. So it's not going to kill anyone. You're still going to be quite a jerk if you try and throw a penny off the top of that. Someone might get hurt. It won't kill anyone, but you're still a dick. Next, human beings evolved from apes. You hear this a lot from young Earth creationists and anti-evolutionists. I didn't come from a monkey. No, you didn't. And no one ever said that you did. Humans and apes share a common ancestor, meaning at some point a species gave rise to both apes and humans. Two different branches. Think of it like this. An early primate had two kids. One kid had a gene mutation that over millions of years gave rise to chimpanzees. Another kid had a different mutation that gave rise to humans. We are descended from a primate, not an ape or a monkey. Right now, we don't know which common ancestor we all come from. We may never know. Water conducts electricity. So while this is a myth, it doesn't mean you should just start eating toast in a bath. And the reason you shouldn't swim in a lightning storm doesn't have anything to really do with the water itself. Pure water is actually an insulator, which means it doesn't conduct any electricity. The danger comes from the minerals and chemicals in the water, which are made up of electrically charged ions. While pure water is theoretically safer on electricity, it's nearly impossible to find in the real world because even distilled water has ions. Salt water is highly conductive, as salt is an electrolyte, which enhances conductivity. So, definitely never use electricity or charge your phone while soaking your feet in an Epsom salt bath. That's killed quite a few people. A common belief in the Middle Ages was that the Earth was flat. We all heard this as kids, at least the Gen Xers, and we've all heard it from flat earthers. Scholars have known the Earth is round for thousands of years. The Greek philosopher Pythagoras first suggested the idea around 500 BC, though his thought process had to do with the fact that he thought spheres were the most perfect shape. Still, Aristotle actually found physical evidence backing up his predecessor's theory. By the time the 1st century AD rolled around, any educated Greek or Roman believed in a round Earth. When Christopher Columbus took on his voyage, the fear was that the oceans would be too big, not that they'd fall off the face of the Earth. Spaceships burn up in the atmosphere due to the friction of air. This also is not correct. The friction of air hitting a spaceship is not what causes it to heat up. Instead, as a ship re-enters, or an asteroid or space rock or anything, it compresses the atmosphere in front of it, creating a compression wave. This compression is what actually heats up the air. This is why re-entry capsules have blunted shapes, designed to change the shape or minimize the compression wave. This is also why the Falcon 9 rocket fires its engines as it re-enters, and why it doesn't require a heat shield. It's the amps, not the volts, that kill you. So that's an old saying. It's not the volts that kill you, it's the amps. Which is true in a way, but not really. So, what are volts and amps? Amps are the unit we use to measure electric current. An electric current is the flow of negatively charged electrons past a given place over a period of time. The flow of electrons creates a current, but it does not happen on its own and needs energy. The amount of energy in each unit of electrical charge is called voltage. Have you ever watched water flow through a pipe? I mean, no, you haven't, because a pipe is solid, but you know what's going on inside. Sometimes it can flow quickly, and sometimes it can flow really slow. And that all depends on the water pressure. Imagine that an electric current is a water pipe. The amps would be like the volume of water. The volts would be like the water pressure. So the amps measure the amount of electricity in a current. The volts measure that electricity's strength. Did you know that your body uses electricity too? Your muscles, lungs, and heart all need electricity so they can work properly. And electric currents travel very well through your blood, as we learned earlier, they are full of electrolytes, which are very conductive. But your skin itself is a very good resistor, which resists the flow of electrons. Therefore, it is very hard to get electricity to your vital organs. This is why stun guns, which can use up to 20,000 volts, and no, a million volt stun gun is not possible. They're lying to you. But they only have about 2 milliamps of current. This is why stun guns don't kill. When the voltage goes up, your skin's resistance goes down. This lets more current flow through your skin to your vital organs. See, it requires both current and voltage to be deadly. You can't be killed by one or the other. You need a high enough voltage to overcome resistance in order for the current to kill you. Anyways, that's about it for now. Be sure to subscribe to get notified when my next video comes out. And again, have a good day.